Hey guys, I'm here to talk to you about functional neuroanatomy, chapter 2, section 4, which is pages 50 through 57. So, to start off, the brain has an elaborate vascular system. The brain gets its nutrients from the carotid arteries, left and right on your neck. They lead to anterior cerebral arteries entering through the skull and middle cerebral arteries too. These are purple for the anterior, right down the middle, and that is pink, as you can see right here, that makes up at least 2/3 of what the cerebral hemispheres need for blood. So, posterior cerebral arteries give blood to the vertebral arteries, which lead to the circle of Willis, or the basilar artery. The circle of Willis connects the essential arteries, and it helps blood flow if any damage occurs to any artery. This damage is usually known as a stroke, and stroke is basically a cutoff of blood supply to the brain. Usually side effects of this are altered vision, dizziness, headaches, confusion, difficulty speaking. We also have something called the blood-brain barrier. That doesn't allow big particles through. It uses the lymphatic system to operate. It makes product travel harder to reach the brain. It's basically a way to protect the brain from any difficulties like viruses from back in the day. Next, we have brain imaging. Brain imaging techniques reveal the structure and function of the living human brain. Angiography, view cerebral blood vessels that helps in diagnosing the vascular disease. More with brain imaging, we have measurements of density can be used to map the structure of the brain. So first off, we have CAT scans, CATs. They measure absorption rates of X-rays by the brain. A picture is basically formed based off of these reflections. It's also used for seeing strokes, tumors, and cortical atrophy. Another one we have are MRIs. They are magnetic resonance imaging. They use magnetic energy to make pictures of the brain that can reveal changes like loss of myelination and multiple sclerosis. Here's an example of an MRI right here. Here's an example of the CT scan. Next we have the diffusion tensor imaging. This MRI tech is used to study white matter tracks through water molecules. Water diffusion occurs differently depending on where you're at in the brain, so we use fractional anisotropy. Where is that? Right here. Fractional anisotropy used for basic imaging of water diffusion while in white matter. So we go over here. Fractional anisotropy. That looks cool. And then we have DTI tractography, my bad. And he basically makes the visual connections made from white matter, so picture all of these connections of the white matter. So that's pretty cool. Next, we move on to the functional imaging techniques map regional brain activities during behaviors. So first starters, we start with the positron emission tomography. It uses injected radioactive glucose to track brain functioning with radiation detectors. So basically, you'll get injected with some sort of radioactive glucose, radiation beams down on your brain, and the radiation picks out where the glucose is traveling. Next we have a functional MRI, also known as fMRI, and it shows changes in oxygen and blood flow levels in images. And it also shows regions of the brain that are active during tasks. Next we have optical imaging. I should probably show you an example of PET stuff, right? PET, fMRI, regular MRI, CT, and DTI imaging. Cool. Let's move on to optical imaging. Optical imaging is, it uses infrared light to penetrate into the brain. When the light bounces back, it shows the activity of those regions. It's much easier to use in labs. Picture it like a very deep penetrating light. And next we have transcranial magnetic stimulations. Based off of this picture, you take an electromagnetic coil, you pulse a magnet field into the brain, and then you stimulate the cortical regions. Transcranial magnetic stimulation records through the use of rapid picture taking. Next we have, this one's a mouthful. We got MEG, the magnetoencephalography. It uses ultrasensitive detectors to detect magnetic fields made by the brain. It's good for showing rapid changes. And then we have the dietic functional MRI. I think that's over here. This one is an fMRI technique used to visualize two brains while people are interacting. Here's an example right here. Basically, they look at each other this whole time. Oh, this is them without them in there. Basically, it's just a way of using social neuroscience. And yeah, that's about it.